All right, today's class we are looking at addition and subtraction of monomials. All right, so here it says we can add or subtract monomials only if the literal coefficients are exactly the same. All right, so what you'll notice then is we can add or subtract the numerical coefficients. You keep the literal coefficients the same. We're going to look at the examples shown below. A note here, the variable and the exponent has to be the exact same. And you may have heard that being called collecting like terms. All right, so if we look at our first example, we have 4x plus 3x. All right, the literal coefficients are x and x here, and they are the exact same. So therefore, we can collect the like terms here. We can add the we can add the numerical coefficients. So 4 plus 3, which is 7, and we keep the variables the same, the literal coefficients the same. All right, so this becomes 7x. So we've simplified 4x plus 3x into 7x. All right, let's look at our next example. All right, so our next example, so the first thing we have to do is look at all of the literal coefficients. They have to be the exact same. So if we look at the literal coefficients here, we have x cubed, and x cubed. All right, so therefore, we can now collect the like terms. So 6 plus 2 minus 5. All right, so that gives me 3x cubed. All right, so our third example here, we have 8a squared minus 9a squared. Again, a squared and a squared there. Our literal coefficients are the exact same. Therefore, we can collect the like terms. So 8 minus 9, which is negative 1a squared, or just negative a squared. All right, usually we won't see the 1 there. You'll just see the negative a squared. All right, next, let's take a look at our literal coefficients here. Z to the power of 5, Z to the power of 5, Z to the power of 5. All right, so we can collect our like terms here. So negative 5 plus 3 minus 2. Okay, that'll give me negative 4 Z to the power of 5. All right, let's take a look at our fifth example. So here we have x squared, and I usually show it in a different color. That it's an x cubed. All right, so here the literal coefficients are not the same. Therefore, we cannot collect like terms. All right, so here you would just leave it as is. So we cannot collect any like terms, so we can just leave it as is. So it is just 8x squared minus 5x cubed. We can't simplify that any further. All right, so let's look at our example here. We have a y squared and we have an x squared. All right, so again, the literal coefficients are different, so we cannot do anything here as well. I'll just show that in a different color. Okay, so this is a y squared and an x squared, so we cannot collect like terms there. All right, so this would stay the same as well. So just 7y squared plus 8x squared. All right, let's take a look at this last example here. We have 12x plus 6 minus 4x plus 13. All right, so what can we collect together? So in an example like this, we can collect together the 12x and the negative 4x. Remember to include the sign on the left. All right, and then we can collect the positive 6 and the positive 13 together. Okay, so you can keep track by using colors, or another method I use instead of colors is like double underline the two things that you can collect together, and maybe a single line under the other two you can collect together. All right, so we have 12x minus 4x. Okay, so just to show that here, so we have 12x minus 4x that we're going to collect together, and then we have the 6 plus the 13 that we're going to collect together. All right, so 12x minus 4x, which gives me 8x, and then 6 plus 13, which is positive 19. So we have 8x plus 19. All right, don't forget the signs. All right, so our next examples add the following sets of like terms. So we have 8x squared and 3x squared. We are able to collect them because they do have the same literal coefficients. So this would become 8x squared plus 3x squared, which would give me 11x squared. 3ab and 6ab, so 3 plus 6, which is 9. So that would give me 9ab. All right, we have 5a cubed, 6a cubed, and then negative a cubed. So again, add 5 plus 6, and then we're subtracting 8. That will give me 3a cubed. All right, and the last one is fractions. So you can put that in your calculator, or if you want to show your work, you can. But our literal coefficient is x, so we can add them. So I'll give you guys a moment to do that. All right, so for that last fraction question, we got 23 over 6x, or 3 and 5/6 x. All right, our next examples, we're subtracting the second term from the first term in each question below. So first of all, make sure the literal coefficients are the same, so xy, xy. So we're subtracting, so 8 minus 9, which will give me negative 1 xy, or you will just see it as negative xy. All right, here you are subtracting, but this will look like negative 8y minus negative 3y. All right, so that does become negative 8y plus 3y, which gives me negative 5y. Good. All right, next we have 13x squared, and we're subtracting negative 5x squared. So again, it does become 13x squared plus 5x squared. So it becomes 18x squared. All right, and here we just have 8, and we're subtracting 9. All right, for the last example here, we have x squared y and then x squared y squared. So those are different literal coefficients. All right, so always pay attention before you start collecting like terms. So since we can't do anything here, we would just rewrite this out as 8x squared y minus 9x squared y squared. All right, and we can't simplify further. Okay, so here we are going to simplify the following expressions by collecting like terms. So our first example here, we have 17y minus 2 plus 8y minus 9. So we're going to collect the 17y and the 18y together, and then we're going to collect the negative 2 and the negative 9 together. All right, so 17 plus 8, 17y plus 8y, that gives me 25. 25y, and then negative 2 and negative 9, that is negative 11. All right, so here we have negative 8x squared plus 16x plus 9x squared minus 16x. So again, look at your literal coefficients. So negative 8x squared and 9x squared can be collected together. And then positive 16x and negative 16x can be collected together. All right, so when we collect negative 8x squared and 9x squared together, we get the 1x squared. And then 16x minus 16x is just 0. So our answer is just 1x squared here. Okay, so for our last one, we have 3x squared and we have 14x squared, and then 5x cubed and negative 6x cubed. All right, so we're collecting 3x squared and 14x squared. So I'll show my step here. So 3x squared plus 14x squared. And then we have 5x cubed minus 6x cubed. All right, so collecting 3x squared and 14x squared, I get 17x squared. And then 5x cubed minus 6x cubed is negative 1x cubed. All right, and just putting this in the correct order, right, in the correct descending order, I would rearrange this. So I would have negative 1x cubed plus 17x squared. I'm just going to try the first one here. So 12x would collect with 8x, and then we have negative 5x squared, which doesn't collect with anything else, and then we have the positive 24. All right, so putting this in descending order, I'd have my negative 5x squared first. All right, and then I have 12x plus 8x. Okay, that gives me plus 20x. And then I would just bring down the plus 24. All right, so this is in a descending order. So we'll have the x squared, then I have my x, and then the constant. All right, looking at this one here, so collecting like terms, I can collect, I have 2x and negative 10x and positive 8x that I can collect together, and then I have 5x squared minus 4x squared. All right, so 5x squared minus 4x squared is just 1x squared. Okay, and then 2x minus 10x, which is negative 8x, and then negative 8x plus 8x, which will just give me 0. So my answer is just 1x squared, or just x squared.